The ultimate fate of the universe is not a dramatic Big Bang, nor is it everything being swallowed by black holes. The true end of the cosmos is far stranger and more reality-bending than any science fiction you've ever read. I'm not exaggerating. This is the future landscape pieced together by scientists step by step using rigorous physical formulas. You might think this is all too distant to matter, but in reality, the sun, moon, and the starry sky we gaze upon every day already hold clues to this ultimate finale. These stars seem eternal, but have you ever seriously considered what the universe would become if one day they all vanished completely? I'm not talking about hundreds or thousands of years from now, but trillions of years into the distant future. By then, not only will all the stars have burned out, but time itself may lose all meaning. Even more incredibly, the physical laws we take for granted could completely break down. Sounds crazy, doesn't it? Don't worry, in the next few minutes I'll show you exactly what the true grand finale of the universe looks like. Hello everyone and welcome to Cosmic Insights. Honestly, we are living in the most brilliant era of the universe, arguably the luckiest generation. The cosmos today is a dazzling display of stars, like a free and luxurious light show. However, this cosmic spectacle is not eternal. The universe wasn't born this vibrant, and it won't stay this way forever. Stars are, in a sense, a luxury item of the universe. The hydrogen fuel they burn was produced all at once at the beginning of the universe, and will never be replenished. The fate of every star is, in a way, predetermined from the moment of its birth. In the 1930s, the Indian-American scientist Subramanian Chandrasekhar made a startling discovery. The final destiny of a star is strictly determined from the day it is born. It's not its brightness or the number of planets it has that matters, but simply its mass. The fate of low to medium mass stars. A medium-sized star like our Sun will swell into a red giant in its later years. Many believe Earth will be engulfed, but in reality, the Sun's intense radiation will push our planet into a more distant orbit, eventually turning it into a cold, desolate world. The Sun will then shed its outer layers, leaving behind an incredibly dense core known as a white dwarf. The magnificent end of massive stars. The most massive stars, on the other hand, end their lives in a spectacular cosmic firework display, a supernova explosion. The energy released in that instant is greater than that of all the stars in the entire Milky Way galaxy combined. Even stranger, the core of some giant stars is compressed into a neutron star, where a mere teaspoon of its matter weighs over 1 billion tons. The most massive and frenzied stars collapse infinitely, warping space-time itself and giving birth to the most mysterious objects in the universe, black holes. However, the death of these stars is merely the prelude to the universe's end. The truly bizarre chapter only begins after all the stars have gone out. At that point, the only protagonist left in the universe will be black holes. We often think of black holes as greedy devourers, but in reality, they can lie dormant for billions or even trillions of years. A black hole is black because its gravity is so strong that not even light can escape. But a little-known fact is that black holes are not eternal. According to Stephen Hawking's theory, black holes very slowly evaporate through a process called Hawking radiation. Near a black hole's event horizon, pairs of virtual particles constantly pop into existence. One particle falls into the black hole, while the other escapes, carrying away a tiny bit of the black hole's energy. This process is incredibly slow. A solar mass black hole would take 1064 years to evaporate completely, while the supermassive black hole at the center of the Milky Way would require 10 by 100 years. For the vast majority of its future, the universe will be a dark, empty space populated by these lonely black holes. They will occasionally swallow stray stellar remnants, but most of the time, they will just float in the darkness. When the last black hole finally evaporates, it will do so silently, without a trace. Do you think that's the end? Not even close. The end of the black hole era is when the truly bizarre phase begins. After the black holes are gone, the universe will still contain fundamental particles like protons and electrons. For a long time, scientists believed that protons were eternal. However, according to grand unified theories, protons do decay, but their lifespan is astonishingly long, about 1034 years. On an infinitely long timescale, even the most improbable events are bound to happen. Eventually, every single proton in the universe will disintegrate, leaving behind a near-perfect vacuum and incredibly dilute radiation. A universe without atoms, without stars, without galaxies. That is the true end. But the story doesn't end there. The vacuum in physics is not truly empty. It is filled with energy fields. Scientists suspect that our current vacuum may be in a metastable state, like a ball resting on a ledge halfway up a hill, which could at any moment roll down to a more stable state at the bottom. If this vacuum decay were to happen, a bubble of true vacuum would expand at nearly the speed of light, instantly wiping out the old universe. Inside this new universe, the laws of physics as we know them would be completely rewritten, and even time itself might not exist. This event could happen at any moment, without any warning, but the probability is extremely low. So, what happens after the old universe is erased? In theory, this new vacuum bubble could give birth to a completely new universe. The cosmos may be undergoing an endless cycle of birth and destruction. But what if, one day, the universe runs out of the energy to restart? It would become utterly empty, cold, and silent. Yet even in this ultimate void, quantum mechanics would still be at play. At the microscopic level, space itself is constantly fluctuating randomly. Given enough time, these quantum fluctuations could spontaneously create anything, including a fully formed brain with complete memories and consciousness. This is what physicists call a Boltzmann brain. In the infinitely distant future, these spontaneously formed, fleeting consciousnesses could even outnumber those that arose through natural evolution. If this is true, it would completely upend our understanding of existence and life. When the universe becomes completely static, with only these random, momentary consciousnesses, time itself loses its meaning. The universe would finally become a place with no past and no future, an eternal now. Faced with such a vast cosmic scale, human existence seems infinitesimally small. But here's the strange thing. We, as tiny and fleeting as we are, have the capacity to understand all of this. The universe has spent billions of years putting on this grand show, and we, perhaps the only audience, have arrived just in time for the most exciting part. We understand the plot, and we can even predict what will happen next. Is this incredibly lucky or incredibly unfortunate? Perhaps the true meaning of human existence lies in our opportunity to understand the universe and ourselves. Whatever the ultimate fate of the universe may be, at least for this moment, you are living in an era where you can ponder these things. We cannot decide the universe's end, but we can decide how we view it.